Dear friends, welcome to my YouTube channel Raju M. In this video, I would like to tell how to download the NACA Airfoil from the internet sources. Then, how we can import that to the meshing software, Gambit software. Then, how we can do the meshing for the airfoil, and how we can do the solver setting and post processing for the NACA Airfoil. Okay. First, we need to go to the Google. Little bit, okay, fine. Google. So NACA Symmetric Airfoil, okay, then you type it, then it will redirect to the airfoiltools.com. Then we can go to that corresponding website for our required NACA series, airfoil series. Those who are in the Department of Aeronautical and Aerospace Engineering, they should know what is meant by NACA airfoil and what is the basic digits like 4-digit airfoil, 5-digit airfoil and 6-digit airfoil. We will take the NACA 4-digit symmetric airfoil. Just we need to click it over there. Yeah, now it's redirecting to the corresponding NACA 4-digit series. So there are different series is available here: NACA 0009, NACA 0012, NACA 2412. These are all asymmetric cases. Okay, let's take this configuration for our simulation. NACA 0012 airfoils. Okay, then you go to the corresponding here source data file. Each and every airfoils having the source data file. Okay, now we can see we can see the source data file for the NACA 0012 airfoil. Okay, then you will redirect to the corresponding coordinates. Just you copy this all the coordinates and paste it into the new text editor. Okay, I am having text notepad plus plus, so just I am pasting it over there. Right, okay, I will create a new one. I am pasting, and we need to save this to the corresponding folder where you are running the numerical simulation. Right, F folder, CAD tutorial and airfoil, symmetric airfoil. Just we have two different already downloaded. Anyway, I will save the new NACA 0012 airfoil. Right, okay, we'll save it. We saved that corresponding coordinate over there. Then we need to open the Excel sheet. I will explain why we need to do this one. So meanwhile I will open the Gambit software for the meshing. Right, okay, I am parallelly opening both Gambit as well as the. So we need to browse the working directory for the corresponding this one, CFD tutorial and NACA symmetric. Right, okay, run. So meanwhile this Excel also opened, so we need to open the empty workbook. So we will open the blank workbook. Then we need to open the corresponding the coordinate in the text file. Is there, right? Yeah, in this one. Okay, F drive, CFD tutorial and airfoil. Right, we have the different files. So new NACA airfoil. Okay, right, to open. So meanwhile the gambit also opened. See, we need to delimited the text file to the proper opening, like proper data alignment. Okay, finished. Then just you delete this one to this one, you put the 0. I will show how the coordinate is there. Delete this one. So in gambit it will take the every point in the three-dimensional format. So here they mentioned x coordinate and y coordinate only. So we need to add the z coordinate over here. We will consider two-dimensional. So in the z direction this will be the 0 for all the cases, right? So again here also the 0. Anyway we will delete this point, no need. Okay, right? Right, yeah. Then I will show how the airfoil will look like over here itself. Insert, here the bar, the plot is there many types, so we'll select the scatter plot for the airfoil. See, this is how the airfoil will look like. If you zoom here, if you increase the here, it's not finished perfectly at the trailing edge part. See here. So what we need to do is like manually we need to add some more point over here. Then I will teach that into the gambit itself. Okay. Then we need to cut this one, no need. We need this informations only. Just copy all the informations. We have the 132 coordinates. Control C. Right, where the point, yeah, this one. Control A and Control B. Then we have the new coordinates with Z coordinate also, right? Control S. The files saved to be, we want to launch it. Yes, okay. One more time we will write on no need. Control S. Okay. Control S. Yes. Yes. So saved or not? Opened in another program, right? It's telling this is open in another program. Let it close this one. Don't save. No, sorry. Close this one. Save. Yes. Yes. Okay. Meanwhile we will see. It's there. We'll check one more time also. Airfoil. This one, right? Yeah, we have the three coordinate XYZ coordinate positions. So this is the gambit environment. In previous video also I showed you. So here what we need to do is like import the vertex data, then browse. So we need to browse the corresponding folder, right? This one, correct? New NACA 0012 airfoil and accept the stuff. See how nicely the airfoil is came. So these are the vertex, means the points. Based on this point we can create the excuse me, airfoil. Yeah, then we need to I already told we need to create one more point over there, right? So that is x direction 1.001 will be good, and yeah, sorry, that won't be good. We'll create 5. Let's see. Yeah, okay, fine. I think this will be good. Finally we'll see how it's look like. We'll see. We will join all the coordinates. Okay, starting from leading edge point, we need to hold the shift button to select the points or curve, whatever it may be in the gambit environment. So I am selecting all the nodes to connect the create as a, so I will make a multiple line, that is not a issue. Sorry, yeah. It will take time. Since the coordinate having, we have the 132 coordinates, we need to join all the points properly to get the proper airfoil shape based on the coordinates. Otherwise the airfoil shape won't be the good. So I am going slowly, right, to understand everyone, beginners especially. Actually these tutorials all will be useful for the beginners in like Gambit or a meshing software or solver setting software such as Fluent or OpenFOAM or any other CFX like that, and post processing software. There are different post processing software is available. I am using different post processing software. Especially I can do some in ANSYS Workbench itself, some I can do it in TechPlot software also. Alright, TechPlot will be the good software for huge data handling, for animation, all the stuff. Still we can do lot of post processing work in the Fluent itself. Okay, it's like a smoothing. Okay, fine. Now I completed the top portion. Now I am doing the bottom portion, right? Since airfoil having the top and bottom, this is a symmetric airfoil, symmetric support the y-axis. So flow for the zero angle of attack, we will get the top and bottom flow will be the same. We'll see that in the numerical simulation results. Okay, those who are in the final year and final year or final year, or those who are interested in the CFD in first year, second year, or mechanical background or aeronautical background or aerospace engineering, chemical engineering. Nowadays the CFD software is using by the many different departments because it's having the wide range of option available. So this will be very useful for the external flow analysis. So many people they can use this technique such as flow over a bus or flow over any sports person in the static position or flow over buildings for the civil structure analysis, how the recirculation will be happening behind the buildings like that. So we can use this software for the many applications, wide range of application. You can Google it, application of the CFD in medical field also there, like flow through a blood pipe or flow through a pipe like blood pipe with the different diameters, and if suppose some of the blockages there in the blood, we can do the simulation and we can predict how the blood flow over there, whether it's the velocity of the blood flow is normal or abnormal. We can do this kind of numerical simulation also using this software. Not only this, we can do the combustion and the heat transfer analysis. Nowadays like a few application like related to the radiation and magnetodynamics, all the people they are using computational fluid dynamics. This is very wonderful software. So now I connected all the points into a edge. Now we need to create the edge into the faces, right? I need to select all, then we will apply. Yeah, good, it's looking good, right? Now we created the two-dimensional airfoil. We can see I selected the different modules there for showing the geometry. So I selected that one to show the this one. Then we can see the wireframe means it will show only wireframe, and right, sorry, it is in the bottom. Yeah, right. Yeah. So now I created the 1 unit length of airfoil in the x-axis coordinates, right? So what we need to do is now we need to create a domain where the flow is coming. Like let's consider the wind tunnel. We need to know what is the test section and where the air is coming and how the flow will be there in the wind tunnel techniques to do the experiments. Similar environmental we need to create in the computational analysis also. So this is the one unit. So let's take x direction in the negative direction. We will consider 10 times, okay, and in the bottom also we will keep that 10, okay. We'll see what's the domain it's coming. Yeah, we are having very bigger domain, so we will reduce in the y direction some more less, okay. We will use -6, we'll see. Yeah, this will be looking fine. So we need to create a +6, apply. Yeah, this will be good. In the y direction or in the x direction we need to increase to 15 to see how the flow will be there after the certain distance, and -6. So we created the point for the test section which is similar to the airfoil, the wind tunnel. So I am creating the line for this one. Then we need to create the now that line for the wind tunnel also, text section also created. Now we need to create the surface for the corresponding test section. That also done. We can see here clearly. Here what we made is like it's like a two surfaces in the same plane. So we are sending flow over airfoil only, similar to the flow over a coil section. I already uploaded the video in the previous session, and flow over a circle also. Similarly, we need to separate this internal test part or test model from the outer domain. So let's do it here. Here there are different options there. Unit, separate, intersect. So we need to separate the top, the bigger, that is showing unit poses, no need. Just a minute, we need to close this one. We need to select the subtract, right? Bigger faces, okay. From here smaller face, right? Yeah, apply. Let's see whether it's separated or not. In this one volume, if you select this one, means we are having only one faces, right? That means it's separated, right now we will see. I will zoom the area, then we will see whether it's separated or not. See, it's separated, right? Then now we need to create a very finer mesh over here for this sections. I will teach how we can do this one. So right now we separated, then we will give the zones, like every preprocessor or solver or need a zones. First itself wall is there, then we will select the wall. Alright, so we will go by step. This is the inlet. What inlet? Velocity inlet, right? Velocity of the flow. Velocity over here, then we need to select the velocity for this from the module, then we need to apply. We can check here with the color and labels. Similarly, for here we need to set as a pressure outlet. Yeah, pressure outlet, right? Apply. Yeah, we can see that is also created. Then top and bottom is a wall. Alright, imagine in your test section and consider that as a test section in the wind tunnel. Consider that as a walls. Alright, apply. Yeah, then this has to be also a wall because this is a pixel position. We'll see whether it's selected or not. Oh, okay, fine. Close and go again. Bring back here, and we need to select shift button and select this all. Right now we created all the stuff, and we need to consider that also wall. Apply. So because of the more points it's showing like that, we will remove the one. Okay, wall and walls. Okay, let it be. We'll completed the boundary condition or zone conditions, boundary condition, especially in the CFD. Then we will go to the mesh, right? Closer to the airfoil, we need to have the boundary meshes. uh, this is boundary layer mesh, right? So this will go the first row into 1.2 times of the factor. Means, example, first line you are giving 1 unit, means the next line the growth factor is 1.2, then 1.2 into 1.2, it will go like that. Okay, we can change the number of rows also. Let's take 10, like based on our, just for this one I will use this one. We'll see how the boundary layer mesh we are going to create over here based on the. Okay, we need to select, right, and first row we will give as a 0.1 unit and see how it's looking like. Then if that is not good, means we will do in the different manner. Okay, oh, oh my god, the length is more. See, you can see this will be useful to understanding purpose. Okay, right, let it see here. Here you can see the smaller, then you can see the higher. It that is the growth factor, the increasing factor. So we can see then how much it's increased. Let's we will reduce this to 0.1, then we'll apply, we'll see how it's coming. Okay, fine, let it be. We will close this one and redo. Okay, fine. So for this one, what we can do here is, like, again we will try with 0.001 unit. We need to select all the coordinates, right? Yeah, you can see. So this and all, like meshing technique for the good results. So let it be, it's looking good. So but there is a vacuum over some edges. So what we need to do is we need to close and we need to redo and fix this one, and again we can go to the one more step with the 10, right? We need to select the one, then we'll see the apply. It's applied. Yeah, I think this will be sufficient for understanding purpose only, right? Growth factor, depth, otherwise we will reduce to 5 times. Okay, this will be looking good. We'll see how it's looking. Okay, because we are doing very fine domain with the fine atomization, so you can see how the meshing is there. This is the boundary layer meshing creating steps. So what I did is, like, I selected the first, then yeah, so remaining we will select a face mesh and we will do the triangle mesh over there. It will come automatically. We'll select, we'll have the only one space, right, and quad payment. We'll see whether it's working or not, otherwise we'll move to the another one. Okay, fine. it's working. Then uh, we can do the refinement. So we can see how the meshing is coming for these cases, for this method. Then we will improve the quality of the mesh. I will show how to do that one. Okay, it's taking some more time since my computation facility, the computer configuration is very low RAM, so that's what it's taking some more time. Meanwhile, I would like to give some important tips for this one, for the numerical simulation. For the better results, we need to do the multiple important steps. We need to do the proper meshing. Then we need to capture the area where you want to do the proper analysis, such as fake big and the circle cylinder, or inside the any flows such as pipes or nozzle flow, or a diffuser section, or a combustion chamber. Based on the complexities, your computational domain will increase, will have the more number of cells to get the proper results. Right now it's taking the long time for the machine. Let it be. I will pause it here. After the completion, I will resume the video. Stop here. Yeah, it's recording fine. Just since my computer is taking like huge time for the meshing, the 50% is done. It's showing. We'll see. Yes, we will change the mesh size or mesh method, because I am here to teach you. I'm not here to do the research over here, because I did lot of simulations and lot of dear friends, due to the huge mesh sizes, so my system not able to handle. So what I will do is I will try to remove the boundary layer meshes for right now. So then otherwise I will try with the triangular mesh. We'll see how it's coming. For the phase 1, okay, close, interval size is 2, apply, okay. I think this will complete quickly. Oh my god, this is also taking time. 99% completed. It's taking time. We'll see how the message is coming. Since my computer is not having much RAM and memory, I'm not able to do the efficient simulation to you people. So still it's messing. Okay, I will again. Okay, fine, it's going. Wow, I think this mess will be very good. Why I am telling this will be good means, since we are capturing very flow field closer to this airfoil, see how fine it is, very see how nicely it's coming. Okay, fine, we'll do the simulation for this one. will capture up to the near field. Up to here the result will be very good. If you want to do the research over here, and let me check whether it's recording or not. It's recording. Okay, fine, mesh is done. Okay, we'll write export the mesh. Here we need to select the 2D option and we need to give the proper name. So 2D symmetric 2D NACA just for airfoil. Alright, okay, accept. It's taking some time to write the mesh. So I will open the Fluent. Meanwhile, I think it's taking time because I'm opening the recent software OBS, which will be useful for screen recording. Okay, fine. Oh my god, it's hanged. Build C, because I'm doing multiple process over here, and mesh it's not returned yet. Still here we can see once it's written, this will come NACA airfoil. I will pass it here once. Oh my god, my system. Here you can see mesh was successfully written to this corresponding name. Okay, then we will close this one right now. Exit, and we need to say before yes. It's saved. We'll close. Why, what happened for the closing? We'll close exit. Okay, finally it's closed. Anyway, this one we no need right now. We'll no need this also. I closed all the relevant stuffs from Gambit. So we'll open the Fluent, right? So I will do the two-part video. First is meshing, because it's having around 300. In the next video I will show how to import the mesh file to a software, and then we'll start the next video. Hi friends, welcome to my YouTube channel RGM. In previous video I created the mesh for the NACA airfoil. I downloaded the mesh coordinate in the Google. So I created the mesh, I shaved into the corresponding folder. In this video I will teach the processing after the meshing, right? So we need to open the Fluent. Let it be. I am refreshing since some process is going here. Okay, Fluent, run as administrator. We'll see how much time it will take. Sorry friends for the interruption. I will pause it here. Yeah friends, Fluent is opened here. I will minimize this one. We need to select the I will do all this stuff over here, then we will go to the Fluent, right? Yeah, we need to select two-dimensional double precision since we are working in the two-dimensional domain. Okay, run. So now the fluent environment will open to you in the screen. Since my workstation is having like low memory, it's taking time. So what? Yeah, friends, fluent is opened. Now we need to read the corresponding case, or here this is a very older version for the teaching purpose I am using. For the newer version it will show read as a mesh itself, but in the older version it's showing the case, right? We are importing our modeled mesh over here, sorry, meshed. Then we need to display the mesh. We'll see. Yeah, we can see how the quality of mesh is like very near to capture good accuracy of the results. Okay, this will be displayed. So mesh is done. When we need to do the process, okay, it's recording, check. And we need to do the redomain for our reorder, right? Reorder domain. Okay, it has to be one for the proper simulations. Okay, it will be like, it will be oscillating like that. We'll keep, okay, fine. Then we need to check information, what's the size. Like we are having 1,04,648 cells. Okay, fine. We will go to the solver settings. Now the grid is done. Define module. We will go to the 2D module, and unsteady cases we will run with unsteady, and second order implicit Gaussian cell based approach. This and all, like you need to study the theoretical part to better understanding behind these numerical simulations, right? I'm just giving the tutorial part for the software only. So define that solver is done. Unsteady problem and viscous we need to set into the different capsulon, I mean like turbulence model. I'm going with this one. Standard wheel, as it is a standard model. Like here you need to read more to understand the stuff I'm teaching part. I'm teaching you. Define the model also done. And space case for model and materials, air will be there, the standard, yeah, the properties of the air, the density 1.225 at room temperature, viscosity 1.789, 4 e power minus 5 at the room temperature. Since we are sending the flow over a airfoil as a air medium, so we did that one, and operating this one, like flow is going this one, and y direction 9.81, gravity, we can add the gravity over there, and define boundary conditions and velocity, set it up, or we will keep around 100 meter per second. Okay, 100 meter per second is the flow airfoil with 100 meter per second. How then we can see how the set is done. Okay, close, define material and boundary condition is set. Boundary condition, operating parameter, that all done. Gravity references done. Okay, that is also done. Define done, boundary condition done. Like in this one, injection no need, unit also no need right now. We need to check the grid at which unit it is there. It is in the meter, 1.5 meter. So it's a long test section. We'll see because we are using the single phase fuel source only, so it won't take affect much for solution control. So turbulent simple model we can use. These are different models, simple like coupling model, PSO and all. We'll use this itself. We are all are using quick coupling and different momentum discretization model. We will use the standard model default as it is. We can do whatever initialization control over is done. Okay, initialization we need to initialization for the velocity inlet and apply initialization is done. Then like solver setting animation define, we will do this no need. In the future I will teach you within volume wall this and all, like advanced parameter for our step plot, xy plot, this one the plot format. If you want plot it here, we can plot it. That also report summary, that we do it later. Forces, fluxes, this is to check a mass conservation conservation through the system. So right now all the parameters is done. Then we need to do the auto saving. So we can do for the 500 frequency, the data is for every 100 frequency. We need to change the name. So yes, it is FOIL, right? Caps dot dz to reduce the memory of your data and case. We'll write one case and data for stocking cases, because we can change the different velocity parameter from this one easily. So that's what I'm saying, the case and data. That is my typical step for the numerical simulation. So it's writing, then we need to iterate. Case and data is done. Okay, solve, start iteration. It will ask the time step. Oh sorry, forgot to add time step there itself. Okay, we'll change it over here. We'll keep 0.01 and we will keep around 5000 time steps. So we'll in 2 minutes, like number of iteration we can reduce to the 10 for the simplicity. So it will run around this means 500 seconds, 50 seconds and just 5 seconds only. So here what we can do is we can increase to 10,000. Fine, apply, iterate. Okay, data sampling, sorry I forgot to do this one. This is very useful for the mean and RMS of the flow. Okay, start iterate. Okay, we'll check few iterations. Yeah, it's going. In the latest version parallel we can see how the convergence plot is coming here, that it's not possible here. This is older version, I don't know. We'll pause it here. After solution is converged, I will show it. I will continue the video. Meanwhile I will pause it here because it will take a more memory. Okay, dear friends, simulation is going smoothly. So right now I will stop it here because it's already around 10 seconds of flow is done. So what I will do is, like, I will stop it here. I will do the some post processing to you. Okay, thank you. I will stop it here. Meanwhile we will save this case and data as a end. We'll do it further when, if you need means, like when we need means we can do further. Okay, alright, end dot gz, right. So for post processing I will continue in the TechPlot software. Before that, just to give the essence, I will open few display here. Grid already be shown here. I will show the velocity contour just to give the essence of this one. So remaining parameters I will display. I will do the post process. Yeah, the TechPlot software. See here, it's taking like huge time since we have the fine quality of mesh. Okay, fine. Okay. So here also it's taking time. Okay, I will do it. Press on right. Hi friends, I already told you that we can do the sum of the post processing in this. So this is the velocity contour over a airfoil. We can see the symmetric about the y-axis. Sorry, x-axis clearly. We can see top and bottom side of the velocity is same because we kept the symmetric airfoil at 0 angle of attack. Suppose for these cases, if you want to increase the pressure at the bottom, we need to increase the angle of attack to create the lift forces for the real-time applications. This is for the understanding purpose only. So I will show you some of the post processing using the another software called TechPlot. Okay, so I will close this one right now since it will consume the lot of memory here. I will close this one, right, end the task. Meanwhile we will open the TechPlot. Yeah, TechPlot. So TechPlot is a very useful software for plotting, post processing, data analysis, all the stuff, especially for the CFD simulations. Okay, so it will take some time to close this one. Suspended. Okay, now it will open. See, because this software OBS, it's taking lot of memory for the recording purpose. So I am refreshing 2 times. So then I will open TechPlot. Yeah, TechPlot is already open. It's loading. Since my computer configuration is very low configuration, so I am loading this one. So temporary invalid local data type to showing some error. We'll see what error it's showing. Okay, fine. Then redrawing all the frames, that is not an issue. It's not responding. It will take some time to come to its original position. Okay, fine. I'm repressing since I'm using like lot of software in this system, like MATLAB, TechPlot, and OBS, and Brilliant, Gambit. So I'm using different software, so I'm not able to work very fast because of the system one. So in this one we have this one based on the cases, and we will select up to this one, will open this one, right? No need to compress. It's loading the data. It's loading the data from top order to bottom order. We'll see the some of the animation for the flow over airfoil and some of the processing and exporting the images and exporting the video to our like required environment. See, this is the domain. Initially I already clearly told you that this is a pressure plot for the 9th one. See, this is how the variation is there. So I will like enhance the plotting by changing the some of the information. Means like we need to do the proper domain area analysis. Means which domain we need to do the calculation. Here the y is up to -6 to +6, right range. Y-axis here +6 is enough to have this one. Sorry, I made a mistake. Here we need to unclick here. Now just a minute, one more time we need to do data fit, and here is 15 and this one is +6, right? Yeah, we can see. Then we will align this one over here in the horizontal manner. Okay, that is legend in this one, and we will keep this automatic. Vertical we will keep as horizontal over the right. Yeah, this is the pressure plot, pressure contour for this one at a different time step. Okay, suppose we need to zoom this particular area, since we can have the better solution control or view over here. Yeah, I'm zooming this area only. See, here we can see how the plot is variation with respect to the time. Then I will go to the velocity contour in the x direction. Just a minute, I'm getting one call. Sorry friends, I got one call. Okay, sorry. So this is the velocity plot over the airfoil for a symmetric airfoil at 100 meter per second of velocity. So we can do the enhancement of the coloring here. Go level, color bar, set levels here, Z0 to 110. Yeah, we will keep 125. Sorry, 125. And number of level we will increase to 21. Then we can see the small variation also with respect to the time as well as the place. Okay, then I will show the yeah, we can still zoom. Yeah, this is looking good, as well as it's like looking, its position is symmetric. So I will plot the velocity vector over here. Here you can see clearly see this one, how this separation is happening. See, because of the very finer mesh, we can able to capture very accurate information at the all the position, right? See, this is the leading edge stagnation point where velocity automatically brings to the 0. Then how the flow is separating based on this velocity vector, I will show better understanding from this streamlines. Okay, we will plot this streamline, then we will come to know how the this is a streamline plot over the one. I will fit into the data fit nicely. Yeah, so we need to zoom some more. Yes, so this is a symmetric cupboard. We can see the same symmetric profile over top and bottom, because so this one, if you want to save this video, you can save, and I already mentioned you that this is the time dependent problem, we can have the solution time over here also. So time is equal to bracket ampersand bracket solution time. If you want to show the time step or like solution time in your plot or like anything, you can do like this, and unit is second. Okay, yeah, accept means yeah, accept. We can do n number of variation here, like modification here, the font size and the font format. Mostly we will keep the Times New Roman. For this one I will yeah, Times New Roman. This one we can increase the space over here, we can change the color for our required color. We can keep the blue color to attract the stuff, as well as the size we can increase. Yeah, so now you can see the time as well as the velocity information at the corresponding single. We can see the animation, see how the each and every time second the velocity over a airfoil is changing. This is the velocity ranges. I will stop here. If you want any more, please comment me in the comment section. I will make a further video. Next video will be the flow area symmetric airfoil, or like airfoil with different angle of attack. Then we can understand like how to calculate the pressure at the bottom and top surface of the airfoil. We will have the better, because slowly I am starting from flow area square and circle and internal flows. We need to give up the all the like easy problems at steady state level. In the initial stage we need to increase the complexity while increasing in the simulation. So those who are beginner for like Gambit software, Fluent and TechPlot software, this video lecture will be very useful for you. Please utilize for this video. In future you come to know in the world computational is going to cover in all the jobs, so it will be very useful for in your future, right? Okay, suppose next video I will show much more information about how to calculate the like a particular plot over a particular line, and how to do the plotting and all I will do. I will stop it here. Thank you for watching. Thank you.